We are Team CRISS Robotics from BITS Pilani. We are a 60-member team working on Eklavya, our next-gen rover prototype.
With the job divided into 5 sub-teams, we are currently in the prototyping and integration.
The mechanical team is tasked with the designing, manufacturing and assembly of the rover.
This year's rover marks a significant upgrade, featuring an expanded chassis to better house internal components. The chassis is equipped with dedicated hardpoints for mounting the suspension, arm and sign systems. We have maintained the reliable 4-wheel differential bar suspension but added individual steering for each wheel, utilizing a worm gear mechanism. The drive system now boasts custom designed 3D printed wheels and a fully floating axle for enhanced reliability. The robotic arm with 5 degrees of freedom can lift up to 5 kilograms. Notable updates include a lead screw driven gripper, a belt driven differential gear based wrist, and a stepper based worm drive for the base.
The electrical team is responsible for developing and designing the powers architecture, the base-driven communication, the inter-rover communication, and handling the onboard electronics.
The rover relies on dual lithium ferrous phosphate batteries and a compact power management PCB with ESP32, relays, and current sensors. This intelligent system prevents current overflow, manages dynamic power distribution, and in case of a power failure, systematically restarts, identifies faults, and restores normal operation. I2C is used as the inter-rover communication system while ubiquity antenna establish the communication to the base station. The drive system enables mobility and steering via DC and stepper motors. A special PCB has been created to operate the robotic arm.
The science team works on the analysis and testing of samples of soil or biomolecules present.
We have custom built a Raman spectrometer which uses multiple lenses, refraction ratings, and the anti-Stokes reading from when a substance is hit with a laser. We also have some chemical tests to detect biomarkers such as carbohydrates, proteins, and lipids. In addition to this, the rover is equipped with a set of sensors, which is used to detect atmospheric gases such as oxygen, hydrogen sulfide, and so on, along with soil properties such as the soil moisture and pH, along with UV and visible sensors to detect certain compounds.
The software subsystem deals with the perception, autonomy, and control of the rover. The rover software, in all aspects, is based on ROS. It establishes an inter-machine communication protocol to effectively exchange information. The ARM works on the MOVIT framework, where we can supply a force to calculate the most efficient path to the final position. For arrow detection, we are using YOLO V5, which has been trained on a custom dataset, enabling it to detect these objects with exceptional accuracy. We are able to teleoperate the rover using a custom 4-wheel drive controller. This, in parallel with the arrow detector and the ROS navigation stack, allows us to autonomously navigate the rover.